Hello my friends. Today I would like to show you something useful to improve your trading skills and to create a strategy. It would be a short video and it would be some baseline for your research. Okay, so first we need to import TensorFlow and K-means algorithm. Then we need to download data. It should be several cryptocurrency. For example, I used the minimum version to create this baseline. For you could download 100 cryptocurrency. Okay, so we download this one. It would be for the last year. Okay, and time series could be different. Could be 1 hour, 5 minutes. It depends on situation, and you could to make this research. Okay, after download this data, we create a big data frame with this cryptocurrency, and you see this one, and then we combine it, and then we do normalization. And when after normalization, what we need to do, let's look in what is normalization. We get this, it would be an array, you see. Yep, this okay, let's again we'll do it. Okay, sorry. Okay, data norm, and you see it will be Bitcoin, Ethereum, and Litecoin. This is price for the last 1 year. Okay, and we do this normalization because neural network is very sensitive, and we need all time normalizate data. It's not random forest algorithm. Okay, then we create our very simple autoencoder. What is the autoencoder? So it would be with only 3 neurons on for output. Okay, we input free cryptocurrency, then we encode our data for only 2 neurons, and then we decode our data only for 3 neurons because we're using free cryptocurrency. For you, if you download, for example, data for the 100 cryptocurrency, first layer should be 100, then you should to encode it. Maybe 50 it will be okay, but we need to test. And the code should be the same like the first layer. Okay, this activate function in general is very low, but you could use also tokens. It also will be working fine. Next, we are going to use activation function liner because we need to reproduce the same data of this data norm. We need to reproduce this data again, and for us it's very interesting would be what is the output in our encoded data. Okay, so a loss function would be square error, and optimizer would be other, but you could change this one. Also add learner rates. It's some minimum version. Okay, and then we feed. You see, feed autoencoder is different. Like you're going to predict some price. We input the same information and it output the same information, and we try to reproduce this one. And then you see we're using encoded to predict feature. It will be some encoded data. Okay, and then I would like to input our normalized data, and we create some columns. This one. Let's look in what happens. It takes some time. So this neural network is very simple, but it's working to create some clusterization. Okay, it takes some time because I'm using 1000 blocks. Okay, and you see we have X and Y. Okay, and next what we need to do, we need to create clusterization. So I'm going to use this information to create some clusters. This information is very flexible, and you should to find the optimal clusters. But this minimum version, so we create we're using K-means, and we input encoded data. Then we create the clusters, and then we concatenate all our information to get these clusters. And let's look at what will be. You see, we have the price data, and we have X and Y and the clusters. We have 3 clusters. But what is interesting in this one? And you see, we do some clusterization. This is, you see, we have some regime. It's like a hidden Markov model, but I see Autoencoder is more powerful thing, and it's like a deep ocean for your researching and create some beautiful trading strategy and powerful trading strategy. So, what is the clusters? The clusters like some regime of the market with different behavior, and you could use this information to improve your trading strategy. And I'm sure using this information you could improve your trading strategy. For example, let's look in something that I would like to create some target. The target would be what is the percent change on the next day, yeah, for Bitcoin. And let's aggregate the statistics. So we split out data on the clusters and calculate the mean, standard deviation, sum, and count. And what's very interesting there. In these clusters we have a different behavior, in general, different behavior. And sometimes using this very simple approach we could find some positive returns. Let's look at like this one, for example. We shift on the 2 lakhs, and let's look at what happens there. Maybe 5 days. Let's look in. Okay, and you see its behavior is different. And what does it mean? It means inside in these clusters we have different behavior, and you could tune in your trading strategy or RCI indicators, stochastic insight in these clusters, and do some optimization and you know, like walk forward optimization when we do some back test and testing. But you could use this walk forward optimization using this cluster without some time series. And okay, this is some to-do list and what you could do to improve your skills and to make more research. Firstly, of course, we need to improve our neural network, because it's very simple neural network, and we need to make this more complicated. So you could also increase number of epochs, number of lives, number of neurons, number of feature, because I'm using only closed data for each cryptocurrency. Also, you could create some optimization learning rate of your algorithm of the optimization. Find optimal batch size. It's also very influential on the results. Find optimal optimizer activation function. Remember, instead of rel function, you could use timings, or do some experiment with loss function. But you need to remember that you're solving problem of regression, because we're going to reproduce the closed data. Also, to avoid overfitting, you could use a dropout rate, and you could use this insight in some layers. If you, for example, add recursive neural network insight in these layers, you could use dropout. Also, you could import dropout from TensorFlow. Okay, weight initialization is also very useful would be for you, and also L1 or L2 optimization. Also find what is the would be the best clustering method. Right now I'm using k-means, and right now we're using like a fixed number of clusters, only 2 clusters, but you could find what is the optimal clusters. And also you could find what is the optimal clusters for your cryptocurrency. Let's fix this one. Okay, and also try to find what is the optimal time lag to hold position. You see, it's a really very big part of work, and you could develop this one maybe 1 month. But if it will be your like baseline start pool and to create something very cool. Okay, guys. So maybe in the next video I'm show you how to implement a few of this feature, but I would like to get from you some maybe some proposal. Maybe you create a git pull on my GitHub there, and of course I save a link under on this video on this Jupyter notebook. Okay, guys, see you next time. Bye.